Today we're going to look at a brand new topic, surds. This is a topic which does build upon things that you know from previous years, but at least at first it will feel like a very new topic. It'll seem quite strange and you will need to battle with it, so please be ready to give this your full attention. Right, first of all, I should explain what a surd actually is. A surd is something like the square root of 2. Or the square root of 3. If you were to put these into a calculator, then you would get a long, non-recurring decimal, which is impossible to write down properly because it runs forever and you can't write it all down. So the only way to be precise is to leave it in this format known as the surd. The square root of 4 is not a surd because it becomes exactly 2, the normal whole number. These ones do not simplify to nice, easy whole numbers. Although you'll be used to calling this the square root of 2 and the square root of 3, from now on we're going to abbreviate that slightly. The normal language that is used for these is just root 2 and root 3. But they are normal square roots. So these are surds. Now, the little bit of maths that you need from our previous topic to progress with this is factors. If you were asked to find the factors of 32, you would hopefully do something like this. You would think through 1, then you'd think through 2. 3 isn't a factor of 32, but 4 is. 5 isn't, 6 isn't. 7 isn't, 8 is, but we've already done it, and so we know we're finished. Now the key thing here is to look at these 6 factors and identify which ones are square numbers. There's the 4 and there's the 16. And generally, it's helpful to choose the bigger one. So you look for the biggest square number amongst the factors. Now this is helpful when you come to a question such as this. Simplify root 32. Because what we can do is we can break that 32 inside the root. We can break it into 16 times 2. And that becomes root 16 root 2. And we know what the square root of 16 is, that's just 4. And so we have simplified root 32 into its simplest format, 4 root 2. If we had used the 4, we would still get the right answer, but it would take longer, it would be more hassle, and it would be more likely to go wrong. Let's just have a quick look to see. We could have broken the 32 up like that. And so what we've got is root 4 root 8. That is 2 root 8. This and this are equivalent, but this isn't in its simplest form, because that root 8 can also be broken up. And so we get to 2 root 4 root 2. 2 times 2 root 2. 4 root 2. Same answer as before. But it's obviously taken a lot longer. Notice it's really quite important that you set these out vertical on the page so that you can keep track of all the different elements of what you're working with. Now, I'm going to get you to try some of these for yourself. If we look at the square root of 48, the surd root 48, I want you to try simplifying that for yourself. Now pause the video and then I'll go through it. Okay, so root 48. We need to think of the factors of 48. 1 times 48, 2 times 24, 3 times 16, that's the one people often miss. 4 times 12, 6 times 8. Now in there we have various options for square numbers. The largest one is 16. So if we go for root 16, root 3, we can say pretty much straight away the answer is 4 root 3. You might have taken more lines over it, that's fine, but that's the quickest, most elegant way of getting there. Now, see what you can do with this one. Simplify root 32 times root 2. There's a couple of ways of tackling this. Pause the video, give it a shot. Okay, as I say, there are different options. You can never know in advance really which option is best. If we work with the root 32, let's just write it in full first of all. We could write that as root 16 root 2 times root 2, so that we've got 4 root 2 times root 2. It's really important not to lose this root 2 that was on the end of the original question. Now, 4, fair enough, times root 2 times root 2. What is root 2 times root 2? Well, there's different ways of thinking about it. Just make a few notes over here. Root 2 times root 2. That is the same thing as root 2 squared. You're multiplying it by itself. And the square and the square root are opposites, and they knock each other out. And so this just becomes 2. So what we have here is 4 times 2. That is one way of thinking about it. If you were to use indices instead, if you really know what you're doing, the square root of 2 can be written like that. And when the bases are the same, and you're multiplying, then you can add the powers. And so we've got 2 to the power of 1, which of course is just 2. So those are two different ways of thinking about what's happening here. But however you do it, we've got that. The final answer is a very easy 8. But if you noticed, this is actually the same thing as root 64, which is just 8 straight away. So we could go that way. A couple more examples for you to try. Simplify root 200 divided by root 8. I'm going to give you a hint straight out to rewrite that as a fraction. Pause the video now and give that a go. Okay. Root 200. That breaks up very, very nicely indeed into root 100 root 2 with a very big square number in there. Root 8, that breaks up into root 4 root 2. Remember, we're always looking to try and find a square number, a big square number, as one of the factors of any surd that we're going to break up. So we've got 10 root 2 over 2 root 2. And now we have to simplify this fraction. Root 2 over root 2 is 1 over 1. They cancel perfectly. They're gone. And 10 over 2, 10 divided by 2, is 5. Lastly for this video, try this one here. 7 root 3 all squared. Pause the video and try that just now. Okay, 7 root 3 all squared. When you square something, you're multiplying it by itself. Now remember what this means. 7 times root 3 times 7 times root 3. It's just one long string of multiplications. So what we have, if we just juggle it around a little bit, is 49 root 3 root 3. Now we saw in a previous example that the square root of 2 times the square root of 2 was just 2. By exactly the same reasoning, this makes 3. We can argue it different ways. We could say root 3 squared becomes 3 because the root and the square cancel each other out. We could treat this as root 9, which of course is just 3. However you want to think about it, what we have here is 49 times 3. 50 times 3 is 150, this must be 147. There we go.